Today we will learn ionization constant of weak acids and weak bases. Suppose we have a weak acid H. Okay, the tendency of weak acid is it ionizes in a less quantity. When we add to this water, then it gets the tendency of acid is the acid gives the H plus ions in aqueous solution. Okay, this is according to the Arrhenius equation. Okay, when you take the acids and put in water, water acts as a solvent, that is aqueous solution. It gives the H plus ions, and that is the basis which gives the H plus ions in its in aqueous solution is a Arrhenius thread. Okay, we have the acid HA. It gives H plus H3O plus A minus. Okay, those ions it produces in aqueous solution. Okay, here the H2O is the lone pair is accept that H plus ion and it will convert it to the H3O plus, and the other parts is a minus. Okay, therefore when acid is dissociated, give the H plus and A minus, and this H plus is combination with H2O, it gives the H3O plus. Okay, that is the one of the hydrogen. H plus is increases in water. Okay, therefore the concentration of H3O plus, okay, remember that the concentration H3O plus is nothing but the concentration of H plus. Okay, therefore this is our aqueous one. Okay, now by applying the law of equilibrium, okay, by applying okay, if there is an equilibrium is there, then we have gives the by applying the constant K is equal to the concentration of ions upon the concentration of the undissociated molecule. Okay, therefore ions in this case is H3O plus and A minus is ions, that is H plus, and the A minus is the ions, and these are the undissociated. HA is the undissociated remaining of HA. Therefore K is equal to given as the concentration of H3O plus and A minus divided by the concentration of HA and concentration of H2O. Now the H2O we have taken in excess amount. Remember that we have taken H2O in excess amount. Okay, if any quantity we have taken excess amount, it considered as a constant. Remember that any quantity which is excess is considered as a constant. Okay, therefore suppose we have around about 1 lakh liter water, and you add this 1 gram, then your water is the excess one. Okay, therefore no effects of this water is happen due to addition of small amount of any compound. Therefore the large amount of water concentration is considered as a constant. Okay, that is a we consider as a constant. Okay, therefore K is equal to H3O plus A minus upon HA, and that is our constant we have taken to this side. Okay, this K is and this is a small one. Okay, K into K. Now we said that the concentration of H3O plus is nothing but the H plus. Okay, by replacing value of this, we obtain this concentration into concentration, you will obtain the new concentration. Therefore Kb is equal to, for this we have to Ka is equal to, okay, small k into K is equal to Ka, new constant. Okay, therefore for this H plus and A minus upon Ha. Okay, therefore the ionization constant okay, that is our ionization constant. For A stand for acid. Ionization constant for Ka is defined as, it is a product of concentration of ions. Okay, it is a product, means the multiplication, H plus multiplied to A minus, product of concentration of H plus, okay, H plus ions and anion. Okay, the A minus is the anion. Okay, the species which is having the minus charge is the anion, and the species having the positive charge is the cation. Okay, in this case we have specific acid produces the H plus ion. Therefore we have defined as this ionizing constant, product of concentration of H plus ions and anion divided by concentration of, that is the Ha. Okay, we have taken the Ha, concentration of undissociated ions, that is Ha. Okay, this is the Ka is we can given by using this formula. Okay, now we will take a specific example. Okay, this was a general we have taken. When we take the specific example, suppose CH3 COOH, okay, it gives, okay, now we not taken it as a, well, we add the water. Okay, we directly it dissociation written like the COO minus H plus. Okay, already we find out the formula of K. Okay, K is the concentration of this upon concentration of that particular acid, undissociated acids. Okay, now this is, there is equilibrium. Okay, to a headed arrow means there is equilibrium. Therefore by applying equilibrium law, okay, by applying equilibrium law, Ka is equal to concentration of CH3 CO minus and concentration of H plus divided by concentration of acetic acid. Okay, that particular acid. Now we have to find out the concentration of CH3CO minus and the H plus ions. Okay, therefore initial concentration of acetic acid is, if you consider C, and at the beginning no atom, no dissociation you found, therefore 0, its concentration is the 0. Okay, then we have in previous lecture one formula is there, dissociation, ionization or dissociation constant is equal to the concentration of ionized ions upon the concentration of the our electrolyte or concentration of acid. Okay, therefore in this case we have to find out this ions, concentration of these ions. Okay, therefore divided by this means the C. Concentration of initial is the C. Therefore concentration of ionized ions is given by C into alpha. Okay, after some time. Therefore concentration, if its initial concentration C, then it gives the C alpha, and C alpha, okay, by using this concentration of ionized ions is a C into alpha. Therefore this molecule, the acid is converted into C alpha concentration of H plus ion. Therefore remaining concentration, okay, the final concentration, okay, after the dissociation the final concentration will be C minus C alpha. Okay, if suppose it is having the 100 molecule, after some time it gives the 10 and 10 this, okay, that is 10 means the C alpha, 10 means the C alpha, and it is the C concentration initial. Therefore the concentration remain, we can give 100 minus 10 is equal to 90 molecules is remain CH3COH. Therefore 100 minus 10 will give the 90. Therefore C minus C alpha is nothing but the concentration of acetic acid. Okay, therefore by putting the values, Ka is equal to ionization constant C alpha into C alpha upon concentration of CH3COH is equal to concentration of COH at the final concentration C minus C alpha. Okay, therefore this C into C square, alpha into alpha is alpha square, C common, we have taken C, 1 minus alpha, therefore 1C is constant, cancelled, therefore C alpha square upon 1 minus alpha. This is equal to your ionization constant for the weak acid K. For the weak acid, ionization constant is given by C alpha square upon 1 minus alpha. Okay, by finding this value we can find out the how many amount the ionization constant you obtain. Okay, the concentration or the strength of acid we can define by using the Ka values. Okay, Ka value defines the strength of acids. Okay, that this is all about the acids. Okay, in this we have seen the ionization constant of acids only. Thank you very much.